All right, hi there. Today we're going to look at 2.1 basic functions and their graphs. And so first off, what is a function? Well, a function can be a set of ordered pairs, and we can see those ordered pairs as called a relation. And a relation can be represented in several different ways, such as an ordered pair, a table, a graph, or a mapping. And so all of these representations are including the exact same values. They're including the exact same x and y coordinate points. Now, what makes it be a function is that your x values cannot repeat. In order to be a function, your x values cannot repeat. So you can't have two x's going to two different y values. So more mathematically, there must be only one output for each input. Simply put, x cannot have more than one partner. If these conditions are met, we say y is a function of x. Also, domain are your x values, and the range are your y values. And remember that all of our points are written in x, y form. So we're going to determine if each one of these is a relation, and we're going to state the domain. And so really all I'm going through and looking at is, do any of my x values repeat? So yes, my x values do repeat, so this is not a function. So no, it's not a function. My domain would be 3 and 4. My range would be 4 and 5. Here, is it a function? Let's look at our x values. I have 3, 5, 7, and 4. So none of my x values repeat. So yes, it's a function. My domain is going to be all of my x values, which is 3, 5, 7, and 4. My range are going to be my y values, which is -2. You don't have to write it down twice if it's written twice. So -2, 1, and 9 would be my range. Remember that domain is your x values, range is your y values. To see if a graph is a function, we have what's called a vertical line test. And what the vertical line test allows us to do, it allows us to just draw a vertical line anywhere on the graph. So I drew this vertical line, and I can see that it crossed the graph 2 times. This is not a function. Because these x values here would have to be the same. I'm totally making up these numbers, but I'm going to say that x is equal to -3, -4 is the name of that point, and I'm going to say that this one is -3, +4. So because those x values repeated, it is not a function. I can draw a vertical line anywhere on this graph. It only crosses one time. So this one is a function. Vertical line only crosses one time. It is a function. And a vertical line crossing 2 times is not a function. And that's how we can use the vertical line test. So looking at equations, we can find out if if y is a function of x. So there's a little hint here. If y has an even power, then it is not a function. Also, inequalities are not functions. So those are the only two times you really got to watch out to see if an equation is not a function, is if y has an even power or if it's an inequality. So here y has an odd power, it's a function. X has a second power, but that's okay because remember it said if y has an even power. This one is a function. This one is actually a parabola. Looks something like that. Y squared, that is not a function. If we were to graph this, that's actually a circle, and you could see that if I drew the vertical line test, it would cross 2 times and it would not be a function. Y squared, not a function. Radicals are functions. I need to be careful on this one. I need to think it's y to the third power, but I remember up here it said an even power. So this one is a function. Equations that are functions can be written in a form called function notation. Guys, all function notation is that f of x equals whatever. So in just a regular equation, it's written as y is equal to 3x minus 8. But for it to be written in function notation, notice we got rid of the y and we replaced it with f of x. So f of x is just a fancy way of writing y. That's all it is. So we already know that x represents the elements of the domain, and y, because we can say that f of x is y, represents the element of the range. So suppose you want to find the value in the range that corresponds to the element 5 in the domain. This is written as f of 5, and it is read f of 5. The value f of 5 is found by substituting 5 in for the x equation. Okay, so for this example here, f of 5 would be 3 times 5 minus 8. And 15 minus 8 is 7. So f of 5 is 7. Now what that does is that enables us to look at this and see that my x value is 5 and my y value is 4. So if we were to plot that on a graph, I could see that that is the point on the graph 5, 7. Evaluate each function. So I'm giving you f of x is equal to 4x plus 5. I'm asking you to find f of 6. Remember, this is your x value. This is what y is going to be because it's f of x equals y. This right here is always going to be your x value. So I'm going to do 4 times 6 plus 5, which is 24, plus 5, which is 29. So f of 6 equals 29. Here I'm going to replace 4 with x plus 1 plus 5. I'm going to distribute the 4. and I'm going to combine like terms. So f of x plus 1 is 4x plus 9. F of negative x, wherever there's an x, I'm going to replace it with negative x. And I get f of negative x is negative 4x plus 5. So we evaluate each function again. So I'm going to replace anywhere there's an x, I'm going to put negative 1. So I get negative 1 squared plus 2 times negative 1 plus 3. Negative 1 squared is 1 minus 2 plus 3. That gives me negative 1 plus 3. So my answer is 2. Here I have x plus 5, that's being squared, plus 2 times x plus 5. Remember, anywhere there's an x, we're replacing it with x plus 5. So here it looks like we're going to have to FOIL this one out. X plus 5 times x plus 5. So first, outer, inner, last. And then I'm going to go ahead and do this, distribute the 2 while I'm at it. So combining like terms, I see I've got 5x, 5x, and 2x. So that's x squared plus 12x. And I've got 25, 35, 36, 37, 38. Okay, some of you may not like the FOIL method, what we did right here. So some of you may like the box. Maybe you've seen that in Algebra 1 or something. It really doesn't matter which way you do it. You end up with the exact same answer. If you just build a 2 by 2 box and you put your 2 binomials on the outside, and then what you're going to do is you're going to multiply the outside of the boxes. So x times x is x squared. X times 5 is 5x. X times 5 is 5x. And 5 times 5 is 25. And so you can see that you end up with the exact same thing. So just another little helpful tidbit if you don't like using the FOIL method. And then here we have negative x. So I'm going to replace everywhere there's an x with a negative x squared plus 2 times negative x plus 3. So negative times a negative is positive x squared minus 2x plus 3 is f of negative x. I'm going to ask you to pause the video and you go ahead and try these and then come back and check your answers. So hopefully you got 13 for the first one, 1 for the second one, x to the 4th minus x squared plus 1, and then I think the one that may have given you some problems is this last one. But what we have to remember is what 3a raised to the 4th power actually means. That means 3a times itself 4 times. And so 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. and then a times a times a times a is a to the fourth. And then the same thing with 3a squared. That would be 3a times 3a, which is where the 9a squared comes from. So hopefully that didn't give you too much English. Okay, I'm going to have you pause the video and try these as well. Okay, so here are your answers. I hope you got those right. If not, let me know. So here we're going to move into a little bit of a different kind. Nothing has changed though. The only thing that's changed is what our equation looks like. But everything's still going to remain the same. We're still just taking -6 and substituting it in. So I get radical -6 plus 6. Notice that that plus 3 is not under the radical. I try to put a little line saying I'm done being in the radical. And so that's radical 0 plus 3. So that square root of 0 is 0 plus 3. If we do 10, we do square root of 10 plus 6 plus 3, which is the square root of 16 plus 3. And the square root of 16 is 4 plus 3, which is 7. Here we're going to have the square root of x minus 6 plus 6 plus 3. That looks like it gives me the square root of x plus 3. Here we have a rational equation, which just means it's a fraction. So, but nothing changes. I'm still going to replace every single x with a 2. So 4 times 2 squared minus 1 divided by 2 squared. Remember to follow your order of operations. Parentheses, exponents, multiplication, and division. So I have to do my exponents first. So that's 4 times 4 minus 1 over 4. So 4 times 4 is 16. 16 minus 1 is 15. And 15 divides by 4. Four times -2 squared minus 1 over -2 squared. Exponents first. 4 times 4 minus 1 over 4. Looks like it's going to be the exact same. 15 over 4. And if we put negative x, 4 times -x squared minus 1 over -x squared. Exponents first. A negative times a negative gives me a positive 4x squared minus 1 over, whoops, I put a 4 down there, over positive x squared. And I believe that is all for 2.1. If you have any questions, please give me a call.